Hello everyone! Today's video is all about area formulas. So these are the formulas that you learned about in geometry. You may or may not remember them, but we're going to review here first, so it's not a big deal. And then from there, we're going to see how we can incorporate what we know about solving right triangles in trigonometry to finding the areas of these same polygons using that trig. So let's review formulas first. Area of a triangle. Area of a triangle is equal to 1/2 the base times the height, 1/2 BH. Something to keep in mind as we go through all of these formulas, your base and your height are always going to be perpendicular to each other. So wherever that's going to be, we'll have a right angle where we will have a base, and then we'll have something that's considered to be a height. So as we go through, everything is, all the heights and the bases have to be perpendicular to each other. If we're talking about a parallelogram, so again, from geometry, a parallelogram is going to be a rectangle, a square. Those are both considered to be parallelograms. So that's going to be just your base times your height. A rhombus or a kite. So again, we'll go through the differences in those later. But right now, the formula for a rhombus or a kite, in order to find the area, it's 1/2 of the diagonals multiplied together. So 1/2 D1 times D2. So we'll go through it when we do an example down below, but see what the diagonals of a rhombus and the diagonals of a kite look like. Area of a polygon. So this formula we're going to reserve for any shape that has 5 or more sides to it. So pentagon, hexagon, octagon, decagon, any of these shapes that have 5 or more sides, the area will be found using the exact same formula, which is 1/2 SAN. So S represents side length, A represents the apothem, and N represents the number of sides. Again, we'll do an example down below. So if you're like, apothem, we'll go through it, and I'll tell you exactly what it is and how to find it. Area of a trapezoid. That one is going to be 1/2. Seeing a theme in a lot of these, right? A lot of 1/2s. 1/2 of the height times base 1 plus base 2. So again, we'll do an example, but a trapezoid has 2 different size bases. So you just add them together. You're essentially finding the average of them. That's why you multiply it by 1/2, and then you multiply it by the height. Perimeter of any shape just means you add all the side lengths. Okay. So that's all of our formulas reviewed. Now let's start putting them into practice. We'll do one example for each, so you can use that as a model to continue. For the first one, calculate the area of the following shape. So we want to calculate the area of this hopefully you recognize as a triangle. So in order to use our formula from up above, we have to figure out our base and our height. So our base is going to be that 1700. And then the height, we need to figure that part out. If we look at just this leftmost triangle here, we see that we have a 30-degree angle. The height, the H, is the side opposite from it. And it looks like we have the hypotenuse given to us at a length of 500 units. So opposite over hypotenuse means we are going to do a sine ratio. So sine of 30 degrees is going to be equal to H over 500. So we just went through a whole bunch of different trig solving problems. So this should hopefully be easy at this point. We find out that sine of 30 multiplied by 500 gives us 250 as our height. So according to our formula, area is equal to 1/2 of the base multiplied by the height. And little calculator work, 1700. Looks like our area is going to be 212,500. Area, if you recall from geometry 2, is measured in square units. Here we're not told what the units are, so I'm just going to write units and make sure it's squared. And that is my final answer. Next shape. This one is a square, or an example of a parallelogram. So in a square, we know that we have all right angles in the corner. We also know that all these sides are actually the exact same length. Also, key point that if we are looking at a square, then that means that this triangle here that we are looking at, where that side's 8, that means that this is a 45-degree angle, or that this is an isosceles triangle. Either way you want to think about it. That should help us to figuring out what the length of the sides are. So we can either do the trig ratio with the 45-degree angle, or if you remember 45, 45, 90 special right triangle shortcuts, you can apply that here as well. We'll be reviewing that as part of our next unit. So if you don't remember your special right triangles, again, not the end of the world. We'll use what we know. And here we can set up a sine or a cosine ratio. Doesn't make a difference. I'll do sine of 45 degrees is equal to x over 8. So I'm going to call that's the side that's x. So again, little trig. So sine of 45, multiply that by 8, and I get that x is about 5.66. So again, I'm using that entire number. I'm leaving it in my calculator so that I can continue to refer to it. So this value of x that we just found, change up my colors, is just from here to here. But this is a square, so that means that exact same value continues up to here as well. So that tells us that our entire length is this 5.66 number multiplied by 2. So our entire length is like 11.3 units long. And again, it's a square, so it's the same on both sides. So in order to find the area, it's at 11.3 multiplied by 11.3. Again, I'm leaving my answer in the calculator so I don't get any sort of a rounding error. And I end up with 128. So 128. The units here are in inches. So 128 inches squared. All right, continuing with these area formulas. This next shape here is an example of a rhombus. So a rhombus has a couple of cool traits to it. One of it is that a square is considered to be a rhombus, and that's because all the sides are the same length around the edges. And also cool is that in a kite and in a rhombus, the diagonals always cross at a right angle. So that means here in this rhombus, we actually have 4 congruent right triangles. So using this information, we know that if this piece has a length of 8, that means this piece has a length of 8. So that means one of our diagonals has a length of 16 inches. We need to now figure out the length of our other diagonal. So if we figure out what this side length is, using trigonometry, we can just multiply it by 2 and then know what the length of the other side of our diagonal is. So trig ratio here, if I need to know this side and I know that the adjacent side is 8, that means I'm using a tangent ratio. So tangent of 30 degrees is equal to x over 8. Tan of 30, multiply that by 8, and I get x here. Part of my diagonal is 4.62 approximately. So again, whatever I have here is going to be the same as what I have here. So I'm going to multiply that by 2. So I get that my second diagonal is approximately 9.24 inches. So again, area formula. Area is going to be 1/2 of diagonal 1 times diagonal 2. Again, I'm keeping that exact same, that 9.24. I'm not getting any sort of a rounding error. I'm keeping that exact decimal that I had in my calculator. I'm going to multiply that by 16. I'm going to multiply that by 1/2. And there I'm going to get that my area is approximately 73.9, it looks like. 73.9 inches squared. Next shape, trapezoid. So like I was referencing before, in a trapezoid, we have two different length bases. The bases are always the sides that are going to be parallel to each other. So we can refer to the 6 as base 1. We can refer to the 8 as base 2. And then to complete the formula, we really just need to know what the height is. So the height is always going to be perpendicular to the base. So that means, again, we need to use a little bit of trigonometry to figure out what that length is. So if we're looking, and note, you can draw it on the other side, right? It's just we don't know what the angle is here. So it doesn't really help us to do that. We're just going to draw the height on the left side because we know what that angle is. So if we use a little bit of trigonometry there, it looks like a sine ratio. So sine of 25.4 is equal to x over 7. And in the calculator, it looks like the height of this trapezoid is going to be about 3. So again, area formula, you have to do 1/2 of the height. Multiply that by base 1 plus base 2. So order of operations here, simplify what's in my parentheses first. So add up my two bases. And then go straight across. So 1/2 times 3 times 14 is going to give us 21. Again, units aren't labeled here, so I will just put that it's units squared. All right, so next shape, polygons. So to calculate the area of a polygon, this is going to take a little bit of work. So I broke it down really into 3 steps. So we're going to say for this example that we want to find the area of an octagon. Remember that our formula, 1/2 SAN, side length, apothem, number of sides. So this formula is going to be used for any polygon that we have where we have 5 or more sides. So area is equal to 1/2 side length. And this again is a regular shape, so all the sides are going to be the same length. Apothem, I will point out what that is in a moment. And then number of sides. Depending on which book that you're reading, what teacher you're talking to, this formula changes oh so slightly. Sometimes they write it as 1/2 apothem times perimeter. That's just an abbreviation of the formula because our side length times our number of sides would give us our perimeter. So that's a variation. The dotted line that we see in this example here is actually our apothem. So this line here goes from the center of the shape perpendicular to one of the sides. And that is your apothem. As opposed to a radius, which a radius is going to go from the center of the shape out to one of the vertices. So that's considered a radius, not to be confused with an apothem. So first thing we have to do is calculate a central angle measure. I know I'm bringing back so much geometry right now. If we are looking at the center of any shape, we see that all these angles together form a circle. A circle is 360 degrees. From there, our little pizza pie here is split into 8 congruent triangles. So to figure out our central angle measure, we will divide that by 8. So this number obviously will change depending on how many sides your shape has that you're looking at. So just keep that in mind. And it looks like we have a 45-degree central angle measure. So what this means is if I just take a look at one of these slices, that's all I did in step number 2. I just looked at one of these triangles where, again, we know that the base length is 14. And now we were able to figure out that the central angle up here is at 45 degrees, but that's that whole angle. If I cut that in half because of the dotted line that's there, I get that one little piece is going to be 22.5 degrees because that's half of the 45, half of the central angle measure. So something also cool here is because once we put this dotted line in, that split not just the central angle in half, but it also split the side opposite from that central angle in half. So that means that this side has a length of 7 and this side has a length of 7, which leads us to then know how to find the length of the apothem. The tangent ratio will help us here because the tangent of the 22.5 degrees will be equal to our opposite side over our apothem. So let's go ahead and plug that into our calculators. And we will figure out that our apothem here is approximately 16.9 units. So from here, we actually can solve for the area now because we have all that we need. The formula again, 1/2 our side length, we were told was 14. Our apothem, again, I'm writing 16.9, but I'm keeping that decimal in my calculator and I'll use that to find my final answer. And then this again was an octagon, so it had 8 sides. So in the calculator, multiply that all together, and the area of this polygon is about 946.37 units squared. And that's it. That is how you find the area of any one of these polygons.